When you solve radical inequalities, remember you've got to consider a few more things here. The first step I would make sure that you do, so you don't forget it, is look at your domain restrictions. Okay, so we want to take our radicands, those things underneath, and make sure that they are non-negative, which means they're greater than or equal to 0, which means we don't want to put any number that is less than or equal to a -3 in for x, otherwise the radicand will be negative. So we want to force all of our x values to be greater than or equal to a -3. For the other radicand, the x plus 7, it also has to be greater than or equal to 0, which means x must be greater than or equal to a -7. Now the restriction that we already have on our x's have to be greater than or equal to -3 will supersede this one, so we really don't need that one. We can disregard that one because as long as we have values that are greater than -3, they're automatically going to be greater than a -7. So now we go about the work of solving our radicals. So it really doesn't matter which one you isolate. I'm going to isolate the x plus 7, and that's going to give me, I keep putting an equal sign, but it's really a less than, 4 minus the square root of x plus 3. So we're going to get rid of this radical of x plus 7 by squaring. So we're going to have x plus 7 is less than, then we're going to square our binomial and get a trinomial. So it's 16 minus, multiply these two together and double, so minus 8 square root of x plus 3. And square your last, which is going to give you an x plus 3. Now we're going to combine our like terms. The x's will reduce. We have like terms of 16 and 3 on the right side. And 16 plus 3 is 19. We're going to subtract that from 7. And 7 minus 19 is a -12, is less than a -8 times the square root of x plus 3. Now I said we want to isolate the radical, and we can still do that. It gives us a little bit of trouble here. Maybe next year when you're in pre-calc you can find another method here that works a little bit more efficiently, but I'm still just going to stick with what we talked about. We're going to divide both sides by a -8. And we're going to isolate that radical. Well, dividing by a negative forces you to reverse the inequality sign, so I got to remember to do that. And a -12 divided by -8 is a positive, and they're both divisible by 4, so I'm going to make it 3 halves is greater than the square root of x plus 3. Now we still have to get rid of that square root of that radical, so now at this point we got to square. So when we square both sides, we're going to get a 9 force is greater than x plus 3. And then at this point, there's a couple of different options that you can do. For me, I like getting rid of that fraction over there, but you wouldn't have to. What you could simply do is subtract 3. So what is 9 force minus 3 over 1? And that's going to be greater than x. So if we do that, we got to get a common denominator, which is going to be 9 force minus, I create force, so I got to take 4 times 3, which is 12, is greater than x. So that means I got a -3 force that is greater than x. And I prefer my inequality, or my variable on the other side, so that means x is less than a -3 force. Okay, so my answers say I only have solutions when x's are less than -3 force. But I also have to come back up here and consider the restriction that we had earlier, which our x values had to be greater than or equal to a -3. So what we're going to do is we're going to pin our answers between these two values. We want numbers that have to be, according to our domain restrictions, greater than or equal to a -3, but smaller than a -3 force. So we want to shade an open circle here and shade everything in between a -3 and 3 force. That's our solution set for this problem.